Ever wonder what you're made of? Well, if you're a science nerd like me, you'll know that everything around us is made of matter. That matter is made of molecules. Molecules are made of atoms. Atoms are made of electrons that circle around a nucleus composed of protons and neutrons. Turns out there are particles even smaller, so minuscule that you can't even see them with the naked eye or any equipment. They're called elementary particles. Of those elementary particles, there are force-carrying particles called gauge bosons and matter particles called fermions. Quarks, a type of fermion, are actually found inside protons and neutrons and are considered the fundamental building blocks of the universe.
But wait! What does this got to do with anything?
You see, there are 4 types of gauge bosons: gluons, photons, and W and Z bosons. Gluons carry the strong force, photons carry the electromagnetic force, and W and Z bosons carry weak nuclear force.
What? Where the heck is gravity?
Well, when scientists tried to add gravity to the other 3 forces using an elementary particle called the graviton, the math just broke. But this video isn't about failed attempts in science, it's about string theory. String theory tells us that inside those quarks, there are even tinier, microscopic strands of vibrating energy, making them the origin of all, and I mean all, matter and force. Take this violin, for example. Each of these 4 strings vibrates at a different frequency to produce the notes G, D, A, and E, respectively. Just like a violin, the strings of the string theory vibrate at different frequencies, producing different elementary particles, including gravity. Oh my god, we could revolutionize the entire world of physics with just this one theory. Well, sorry to burst your bubble, but string theory cannot bring the band of forces back together in our universe. You see, our universe consists of 4 dimensions, 3 spatial dimensions of length, width, and height, and 1 dimension of time. For string theory's mathematics to work, we would need 11 dimensions, meaning 10 dimensions of space and 1 dimension of time. This theory suggests that there are 7 additional dimensions, but not as we would think. These extra dimensions are actually compressed together, like a ball of paper, into a shape called the Calabi-Yau. Because we cannot see these dimensions, we do not know the exact shape of the Calabi-Yau. If we could find the exact shape of the Calabi-Yau, we could calculate the vibrational patterns of the strings. With string theory, we could study the properties of the big and those of the small with just one theory. Something that once seemed like science fiction will finally become a reality.